Hi again. Sorry, my video got cut off, so I'm going to start where I left off in the other video. So this is lecture 2, a continuation of lecture 1, projectile motion. And what I'm going to do is kind of describe how to solve or start solving these problems using our equations. So in the last video, what we had, let me get my pen going. Oops. Oops, too far, sorry. There you go. So in the last video, I started describing, what's going on here. So, why did I just do this? Sorry again. I want this one. Thank you. Finally. Okay. I was describing how we needed to describe our motion because we have two directions. So just redrawing what I did. If I wanted to find the velocity at, if I had the projectile at a certain location, say it's over here on our motion, that remember it's going to have a y position and an x position, like that. So notice I use y and x, but some other symbols you can use is dx, as I have right here. You could also refer to this as the range. This specifically means horizontal. And same thing, you could write it as y, you could write it as dy. And two words that represent the vertical measurement is either height or altitude. So those are some other measurements that you can use that will signify a vertical direction. And same thing, this object's going to be, actually in this case, it's going to be moving horizontally in the x and vertically in the y. Now I drew the y down in this case because it's moving in the downward motion. So that's why we need these two equations to solve for it. And like I said, this is constant motion, so there's no acceleration in the x direction. So that limits our equation. So Vx is equal to dx over t. However, if you look over here, we have multiple, basically these are the kinematics. I mean, I didn't really do anything different here. But what I'd like to do actually is just signify that these all refer to the x. So actually, let me just do a quick little change here. Although this is true, I want to keep these more generic, like that. And these are all y's. So in other words, it's VFY. I don't know if it'll let me change it right now. So let me just do it like this then. Let's start from this row. So I'll do it here. I mean, these are fine, but I'm just going to write them so they're a little more clear. So x, we have the Vx equals dx over t. The y, all kinematics, because there is an acceleration in the y direction, and for all of projectiles, acceleration is going to be constant. And the negative refers to the downward direction of the acceleration. So a is the same. So that's a given value in all of these problems, which is really helpful because even though we feel like we have no information, we do, we have that. So here we go. So you have Vy squared final equals Vy initial plus 2a delta x. Now remember, I refer to a vertical measurement, so you can actually write this as y, but this is fine. Point being, this is all in the y direction because y is changing over time. So that's why I'm spending the time to write it as VIY. Most common mistake made on all exams is mixing up x and y, so do not. So what I mean by that too is a lot of times problems might just give you a Vx and no Vi, but you're desperate and you want to put a number somewhere, so you put it in here. So do not do that. It's not the way to solve it. So just careful with that. And I notice that on exams, it's very common. People do that. They mix these up. So just try to be cognizant of it. Just be careful. So you have a plethora of equations to use to solve for our motion here. And since we have two motions, we will always need two equations. To solve these because we have two motions going on here. Now the key to this is that when we have that projectile moving from here to here at some point, so let's just do it for right here. This is the ground. That it takes time to go in the x direction. Well, it takes time to go up and down in the y. So actually this is a bad depiction of the y. It's hard to draw it because it's actually moving too. So let me just do this. Let's do x here and y here. And I'm just going to do it with my pen. So it's going to take time to do this. But remember, at the same time, the object is going up and down, which means the thing that we're going to relate between these equations is time. Because it takes the same amount of time here and here. So that's how we're going to connect the two equations. If I know time for here, I can use it for here. But I have to be very careful, because in different problems, times mean different things. What I mean by that is, for example, if you want to find range, or the x, you want the time at the final point. And the reason why is because when you start here, you're going to end here. So that's your final point there. But time for maximum height happens at a different location. So although time is the same in x and y, notice that if I found the time at this location, it will give me this x and this y at the max height. But if I use the time over here, it's going to give me this distance and this height. And if you notice, at max time, it returns to where it started. So delta y would be 0, which is actually not helpful, right? Because although it's true the height is 0, it may not be helpful for other parts of the problem. So just careful with time. Time will work at that location. So time is same at specific location. And you'll notice how I change my times depending on what the problem wants. So just be careful with that. So in essence, that's how we're going to solve these problems. And of course, as always, seeing the models of these problems will start connecting these ideas. So this is just a summary of the x motion, which I talked about. So you can read these on your own. And then the y motion, same thing. Like that. So I'm going to skip through this. Okay, so I'm going to end here because I'm going to do the problems in the next slide. I'll solve 3 types of horizontally launched projectiles, and I'll solve a couple types of projectiles launched at angles. So this should help you in your homework and help you with lab.